Hello, ladies and gentlemen. Today I want to talk about the Earth. Once again, the Earth inside boils like a pot of water. And here's why. I'm going to go right down here, follow my mouse. What I have visible on Google Earth right now are the 6 primary vortices. If you notice right here, we have North America, and this is Canada. And we have the North Pole right about right there where my cursor is. This is the Arctic vortex. Then on the opposite side of the planet where you can't see it down here, we have the Antarctic vortex. Those two vortices connected create the polar vortical rod. Then we have 4 vortices that wrap around the planet's equator. And right here we're looking at the Pacific Oceanic vortex. Over here we're looking at down to the lower right of my screen, we're looking at the Winnie vortex in South America. Over on this side, we are looking at the top right now, where my cursor went, we're looking at the North Banda Basin vortex. Sorry, it took me a second there. So, from this point of view on our planet rotates in this direction following my mouse. It rotates around the North Pole like this. Alright, this is how mantle convection works for the scientists who are interested. All of these vortices around the equator of the Earth are anti-cyclonic. So what that means, ladies and gentlemen, it means that right around here in the middle of the Pacific Ocean, it's probably covered up by oceanic sediment. Okay, and there's a vortex, and it goes and sucks everything from the top of the planet down in toward the core. Why is that? The reason that is because gravity is its strongest around the equator of our planet and weakest at the poles. Now I have this particular screen of our planet in this very perspective because I'm trying to illustrate to the viewer that our planet is flying in this direction. This is, if you were to look at our planet going through space on a normal plane, like in my room, if I was to display the planet Earth, if I was to set my globe on my desk, the North Pole, ladies and gentlemen, would not be at a slight tilt of maybe 25 degrees, 23 to 25 degrees, on the top of my desk, because that is a false representation of how our planet actually functions. Our planet flies through space. One second, excuse me, Boomy. Oh, thank you. I'm gonna borrow Boomer's ball. This is Boomer's ball. You notice it's shaped like a football because Boomer is his favorite toy. Now you notice that each one of these longer points represents the North and South Pole, and then around that we have the equatorial vortices. Okay, and this is Earth flying through space. That's a concept, right? How does the football best fly? We don't throw it like this. Here, try and catch that. Whoever runs farthest, okay, toward the correct goal. Okay, yeah, I'm the guy that always ran toward the wrong pole because I didn't know which pole was the right pole. Oh, wait. I mean, goal. Freudian slip, right? All right, so here's planet Earth flying through space, and you notice that I'm going to go ahead and give it a slight upgrade. In this, not meaning, something new. Gradient, let's call it that, up gradient. So this is my North Pole. And as you're viewing my North Pole, you notice that it's a little bit higher than my South Pole. Well, it's also because Earth is not just rotating like a football, it's also keeping its nose above the water, right? The gravity waves, the supermassive electromagnetic gravity waves, are flying from behind like this and coming right up and slapping the planet right here in the rear and giving it a good thrust forward. And then you have the resistance coming in on this side, or what some might refer to as the bow wave. All right, and this is the butt wave. Or maybe we'll call it the stern wave. All right, this is stronger. And this is what's actually forcing the planet through. And it creates, because these supermassive electromagnetic gravity waves, SMEGAWs, create and generate their own gravity to basically, they're kind of like relay stations. They got the gravity, the primary gravitational force that is being emitted by, or not necessarily emitted, but generated by our parent black hole out of 3 black holes. It comes around, it's got its own gravity, and then when it basically takes the supermassive electromagnetic supermassive electromagnetic waves, okay, or braided field ropes, they're coming out of the poles of that black hole, just like magnetism out of our planet, and then they swoop back around and come in like this onto their plane. And as they do, they're rolling. So as they roll, because they develop their own vortex, in a sense, a linear vortex shaped like a rope, they generate their own gravity. And as they're generating their own gravity, we then have galactic gravity striking the planet at the South Pole. So there's 2 forces working here that cause our continents to spiral this way, because basically the planet is rotating this way, and it's more like the continents aren't rotating at all. The planet is, the continents are like, heck with that, we want to stay where we are, so they go westwardish. All right, so you also have you have a few things. So you have the bow wave force here pushing the continents toward the South Pole. You have the gravitational, or the galactic gravity, striking the South Pole and bringing those items down, and like this is the bottom of the planet in a sense. And then you have solar, the coefficient of solar wind pressure drag that's also helping force those continents in a spiraling southward, westward manner. So, but this particular video is supposed to be about mantle convection. A mantle is no different than anything normally that you boil in your pot. It circulates. So as the anti-cyclonic vortices around our equator are basically sucking material in, they're not currently sucking material in at the crust. Please, you have to work with me here. Our planet it's not solid. Never think of it as solid. It is harder, near solid around its shell, but it's not completely solid. But because it has that shell, all of this activity generates and operates underneath of our shell. So it still has the vortices all the way around the planet in the way that they work. They're still taking matter inside the planet and pulling it in toward the core. As they pull that matter in toward the core, follow my mouse now, they're pulling it in out here, they're spitting that material out at the poles. So it's first coming in at the equators, pushing out toward the poles, and because there's a shell that they can't actually push the matter out into Pangaea, the north, as we tend to consider the north at the top of whatever, and the South Pole being Antarctica, instead of spewing out the material in those manners, they're recirculating that material back around the outer shell and reinstating that very same cycle all over again. So you have this boiling pot of water inside the planet. That's pretty much how it works in the most simple form. And what I'm going to do is go to my new folder here, and this is going to be a picture of kind of like a cross section of our planet that will show us. I apologize for the slow computer. It's going to take it a minute to pop this on, I think. Or is it just not going to work for me? Is it slow? Is that it? Oh, now it's going to work. Thank you. Jeez. All right. Here's my cross section. Kind of pretty looks complicated, kind of looks like a flower. All right, so we have the core in the center, we have the mantle going around the core, then we have the asthenosphere around the mantle, then we have the lithosphere, the lithosphere around the asthenosphere, and then we have the crust around that. And this particular slide is basically telling us a theory on how these inner spheres work together, because as Jupiter has its backflow in its jet streams, we have spherical backflows in the interior. And as all this material works together in the manner that it does, we also have the vortices that go around the equator, and these black lines indicate how the anti-cyclonic vortices are pulling matter in at the equator to push it out at the poles. Okay, now that shows that one. I think I can go ahead and push this and look at my next one. This one here gives us an idea of how our planet is flying through space in relation to the galactic core, which is here. As a little plus, I put galactic virga at the top of the galaxy and at the bottom. In our galaxy, we have virga at both the top and the bottom. Because the continents are being pushed toward the South Pole in a spiral manner, they also create virga. In this case, we would refer to them as continental virga. All right, now the galactic base is down here. The universal jet stream is what is striking the galactic base. Ladies and gentlemen, our galactic base is 1/3 less than the galactic head. And that doesn't just happen to come that way. There's something that makes it that way. And the reason that our galaxy is shaped like this, it's more conical than anything, it's because there's force coming up underneath of it. That force is our universal jet stream. Now, over here, we have the smeagol's from the galaxy that are striking our solar system. This blue disk right here is our solar system. This is this line around our planet is basically the best I could do for an illustration of our ecliptic in relation to the solar plane, right? And so the smeagol's from the galaxy are striking the base of the planet, pushing this whole entire solar system in this direction of our parent black hole's direction of rotation. Okay, the center of our galaxy is actually rotating in the opposite direction. Just like you have the North Pole, the vortex at the North Pole and the South Pole are rotating in the opposite direction as the planetary rotation. Okay, now that's pretty much how it most simply works in terms of where the forces are coming from. And it's actually our parent black hole in the galaxy that rotates our solar system. So as these waves are coming from behind, and they're being like ropes coming around like this in a spiral, it's these smeagol's that actually form our galactic spiral density waves in the form that we see where the galaxy is spiraling out in its arms. All right. Those are not the forces that drive the solar system as it is. It's the smeagol's are the invisible forces behind those spiral density waves. The spiral density waves are visible because they are held together through electromagnetic force and gravity of their own generation between giant blue stars, which seem to tend to congregate toward the center of the galaxy along these spiral density waves. And then they have a whole bunch of other little guys that hang out with them, like a clutch of frog eggs in a pond. So if you were to stir the pond with a clutch of frog eggs in there, you can imagine how some clutches might break apart, and then they start to form spiral arms because of the rotational activity of the vortex, very weak vortex, but the vortex you're nonetheless creating by stirring the water. Okay, that is everything in its simplest form right there. And when you have the interior of the Earth sucking in matter and then pushing it toward the poles and then coming around and recycling that matter, on the North Pole, that's what helps feed the Yellowstone supervolcano. In the same essence, it probably helps feed the theoretical Taklamakan supermassive volcano, except that maybe the Taklamakan isn't growing as much as Yellowstone, probably because it has a way heavier, greater mass of crustal earth above it, and it's not as easy to push up. America is not quite as thick, I think, if Mount Everest is any indication. Okay? That concludes this video for today, ladies and gentlemen, and I shall be letting you go. Or should I? Maybe I have one more. Oh, I do. Hey, my apologies. That's one of the advantages of being old. Nobody cares. You just rattle on anyway. So here it is. Here's the last one I wanted to talk about, right? Got the sun over here. All of these little flares and things and all that stuff coming off the sun and, coefficient of solar wind pressure drag, as I have it written down here, comes and blows around the planet, pretty much blowing these continents in a westward direction. It blows them in a westward direction. Centrifugal force and gravity are basically combined with, more likely pressure. So you're getting hit from the rear end, and that's making everything go toward where that collision is taking place. That takes place every 11 years or so. And that's right, I said every 11 years or so, because that very same cycle of waves, the Smeagol's, are theoretically the driving force behind the agitation of our sun every 11 years as it reaches solar maximum. So as the crests of these Smeagol's reach our solar system, they agitate the sun's surface and make it do all kinds of cool things on the surface, right? And then as they pass by, the sun calms down. And as they pass by, our solar system is going back down into the little valley. And as it approaches in the next 11-year cycle, our solar system starts to rise on the swell like that albatross on the swells of the sea, going up. And it doesn't ever look like the albatross is going anywhere. You're sitting in the same spot as what it looks like. He's just going up and down, up and down. And that's kind of what we do. But we are moving, and so is that albatross, just not as fast as the waves. All right, now as we're looking over here, the falling of continental virga. This is what I refer to, how the continents are coming down by, all three of the combination of forces, which are what? Oh, probably the bow wave from the front of the forces that the solar system hits as it's flowing forward in the resistance that it gets, and then from the rear end, which is an even stronger resistance, where the galaxy is affecting the base of our planet to make the base of our solar system and the base of our planet all the same type of energy. And then you have, of course, I think that's it. I was on a roll and then I dropped, oh well, I'm old, I get away with it. Okay, so here you have the North Pole. It's rotating in the opposite direction of the planetary rotation, which is going, if you follow my mouse, the planet rotates in this, normally, rotates in this direction. All right, now, what is it that makes planets rotate? Well, in this instance, there is a correction I need to make, ladies and gentlemen. And before I said that planets that rotate in the opposite direction, that are not rotating prograde but rotating retrograde, are doing so because they are outside the influence of the sun's electromagnetic gravity waves and closer to the influence of the galactic waves. What I'm going to correct is if they were closer to the galactic waves, the SMEGAWs, and being influenced by the SMEGAWs rather than the EGAWs, they would rotate in the same direction as the sun. Why? Because it's the SMEGAWs that rotate our sun. So I have to correct myself on that. That leads me to suggest this new theory. The coefficient of solar wind pressure drag and solar wind pressure is stronger than electromagnetic gravity waves. Okay? But it has a short range influence on its solar subjects. And the greater range influence will then revert back to the EGAWs, in which case the EGAWs and the SMEGAWs, like the SMEGAWs, they function like gears. So that means that everything that they contact rotates in the opposite direction as the parent object that's rotating and emitting the EGAWs. So in this case, the sun is rotating as it does, okay? And as it's rotating, it only has enough influence on the planets to make the planets rotate in the same direction as if they were rolling around the sun on a solid surface. That's how forceful solar wind pressure is, up to the full extent of its shortest range. Okay, now beyond that, we're getting back into EGAWs. They go and they twist all together because they're electromagnetic braided field lines coming together, twisting together as gravity pulls them in. Okay, so as it does that, then the SMEGAWs cause the planets that fall into that range, or that area, and those ranges, to rotate in the opposite direction. So they rotate in a retrograde direction. And that doesn't mean that you can't have a planet closer toward the center of the sun, say for instance Venus, and it be so close that it theoretically should be rotating in a prograde direction. Not if it is so high above the influence of the sun's solar wind pressure that it's actually now being up here, being more, because as it eclipses the sun, it kind of has this appearance. Follow my right finger. It's up here at first, and it goes across the sun like this. So as it's going across the sun in this manner, it's up here. It's coming down. It's not in that equatorial region. It's not in that solar plane quite the way maybe some of us others are, and so it escapes the influence of solar wind pressure to the extent that it is very possibly being more influenced by the sun's electromagnetic gravity waves, in which case they cause it to rotate in the opposite direction. If that opposite rotational direction is relatively slow, that's because you have the planet in a particular setting between the two forces where it's kind of like you're pressing on the gas pedal in your car, and at the same time you're pressing on the gas pedal on the car, you're dragging the brake. So you're pressing the brake just a little bit. When do we do that when we're driving? Well, if you're getting ready to tow another vehicle, you're dragging the brake with one foot while you're pressing the gas with the other one. Because if you press the gas with the other one, you're going to go forward too quickly, snap the line. So you want to bring the car forward to get that line taut, and you're dragging the brake as you do. You continue to drag the brake off and on as you're pulling the car in order to prevent the line between the car being towed and you from slacking, and then you having this doink, doink. Every time you go doink, there's only so many doinks that can happen before that line snaps. What happens when a line snaps? Very dangerous. You could have one of those hooks come off the other vehicle if it damaged the vehicle in the process of going doink, and now you have this hook flying through the air. Clobber somebody, clobber a car, break a window, break some bones. So that's the kind of thing where That's the an example of where you would be dragging your brake at the same time, right? So you basically have the planets like Venus or whoever, and they're in that relative zone where they are actually being influenced by both forces, but one is slightly stronger and more influential than the other. Okay, now I will have concluded my video, and I gotta go ahead and get ready for work here. Oh yeah, I'm doing good today. Okay, bye.